The lunar phases are probably one of the more difficult concepts for astronomy students to understand, and so I developed this Lunar Phases Worksheet to try and help students figure out when a particular moon phase would be rising, when would it be up highest in the sky, and when would it be setting. Just by taking a look at a picture of the moon, given a moon phase, you should be able then to figure out just from that picture, it's like, okay, that particular moon phase, I know it's a waxing crescent, and then it would rise at at this time, and it would be up highest in the sky due south at this other time, and then it would finally set at this other time. And I want you to be able to do that for any of the moon phases. But that is something that can be a bit hard to figure out. So that's why I created this worksheet to do it. And rather than having you work on it, by yourself, I found it's better for me to go through this in class. And for an online session, I have this video set up for you. And as we're gonna go through it, the Lunar Phases Worksheet is there in your student guide. I'm just going to go through it step by step. And the nice thing about a video is that if there's a part that isn't clear, you can stop the video, rewind it, and listen to that part again to see if that makes more sense when you hear it a second time or maybe even a third time. So let's go ahead and get started with the first page of it, which is just about the sun position and the time of day. I start off with this because the phases of the moon are determined by the position that the moon is with respect to the sun on our sky. And the time of day is determined by, well, where is the sun on our sky? When the sun is rising, well, that's sunrise, and when it's up highest in the sky at noon, it's due south, and we say we say that's noon time, and then the sun would be setting at 6 p.m. And for simplicity, we're going to really simplify everything down so that we don't have to worry about, is the sun rising in the northeast, or is it in the east, or in the southeast? That is, dealing with the different seasons. We're just going to have the sun rising just right there in the east. It's going to be up for exactly 12 hours and set there, exactly in the west, again, for this very simplified model. We will also have the moon doing the same thing. The moon will be rising there, right there in the east, and it'll be setting right there in the west, and it'll be up for 12 hours. So for this first part here, just says fill in the boxes with the time that the moon is at the position in the pictures below here. And we have the moon rising at 6 a.m. And so we know that it would be here at noon. Go ahead and put that there at noon. That's supposed to say noon. And then I could just put in some other times. I know that these times here would have to be in the morning, sometime between 6 a.m. and noon. And I'm just going to go ahead and say that this is 8 a.m. This is 9 a.m. Oh, actually, you notice here, it says halfway to midpoint. If the sun is up for exactly 12 hours from rising to setting, that means from rising to being up at the midway point is how many? 12 hours divided by 2 is 6 hours. So from here to there would be 6 hours. And then it's saying this is halfway to that midpoint. Well, what's half of 6 hours? Well, that is 3 hours. 3 hours after 6 a.m. would be 9 a.m. 3 hours after 6 a.m. we would have it there at the midway point. So I know that one's got to be 9 a.m. And by the way, you look over here, it also says halfway to setting. So that means it is 3 hours after noon and 3 hours before 6 p.m. So I know that that one's got to be 3 p.m. So I might as well go ahead and put that one in as well. And then I got to put an intermediate time here. I'm going to say that's 11 a.m. just because this position looks like it's closer to noon than it is to the 9 a.m. position there. And this one looks like, this particular position looks like it's closer to noon than it is to 3 p.m. So I'm just going to say that's 1 p.m. For that one. And then this one here, I'm going to say is 4 p.m. just to make it being 1 hour after this midway point, just like this one here was 1 hour before that midway point there. So just to make it nice and symmetrical. Okay, so we have, it says here, all objects rise somewhere in the east and set somewhere in the west. Objects that cross the meridian up to 12 hours before the sun crosses the meridian are said to be ahead of the sun. And that means that they would rise sometime between 6 p.m. and 6 a.m. and then cross the meridian sometime between midnight and noon. Objects that cross the meridian up to 12 hours after the sun are said to be behind the sun. So that means that they're rising between 6 a.m. and 6 p.m. and they're crossing the meridian sometime between noon and midnight. So for objects A and B here, it says indicate whether they are ahead or behind the sun and fill in the box with the time that they would reach the meridian. Well, here at noon, we're going to take a look at object A, and I'm going to have my one finger, my index finger, my pointy finger on A, and then I'm going to have my pinky here on the sun here. Now, 3 hours ago, 3 hours before this particular snapshot was taken, these objects were more like this. The sun was over here, and then this object was just beginning to rise up. Then by noon, they would have moved to being right here. And then it means 3 hours after that, the sun would have moved over here, and then that object A would have moved to being on the meridian. So as these objects move across the sky, then for object A appears to be trailing behind the sun. And so we would say that this one is behind the sun. So I'll go ahead and circle behind there. And what time would it finally reach the meridian? Well, at noon, it is still here in the southeastern part of the sky, between south and east. It's here in the southeast. It says it's halfway to the midpoint there, which means it's about 3 hours behind the sun. So it's going to reach the meridian 3 hours after the sun does, that is 3 hours after noon. So we know that this one, it's going to reach the meridian finally at 3 p.m. At noon, it's right here in the southeast. 3 hours later, it will have moved this way. So at 3 p.m., object A will be right there on the meridian, and the sun will be over here where my pinky is there. Now let's take a look at object B. Object B is, well, now if I have my index finger being the sun and the pinky being object B, we can see that as it moves across the sky, it's moving ahead of the sun. So it's going to set before the sun does, that away. And so we know this one is ahead of the sun, because everything, rises in the east and it moves this way. It moves from, left to right across the page here, from east to west, if we are facing towards the south there. And figure out, well, what time did this thing reach, did it reach the meridian there? Well, that word there, reach, tells you that it has already reached the meridian before the noon time here. So that's a little clue to you. It's got to be before noon. And it says halfway to set position there again. So it's 3 hours different from the sun. From there to there is 3 hours, and from another 3 hours from there to setting there. So we know this has got to be a 3 hour difference of time there. And it's got to be before noon time. So at 9 a.m. is what I would put in for that box. So at 9 a.m. that object B was right there. And if I go, well, if I have my pinky being object B and the sun being at my index finger here, 3 hours ago, so 3 hours before noon, they were like this here. So object B was here on the meridian at 9 a.m. and then the sun was off over here in the southeastern sky, which would correspond to 9 a.m. Time that we had there. Okay, now we're going to bring in the actual moon here. As the moon moves around the Earth, we see varying amounts of the lit side of the moon. When the moon appears close to the sun on our sky, we see less of the lit side and more of the night side of the moon than when the moon is further from the sun on our sky. So the larger the angle is between the sun and the moon on our sky, the more of the lit or day side of the moon we see. That is, the fuller the moon appears. In the picture below are various positions of the moon with respect to the sun. The time of day is noon, and how do I know that? Because the sun is, in this snapshot here, this figure 1, the sun is on the meridian right there at noon. So the time of day for this snapshot here is noon. And then we have these possible positions of the moon at noon. And we have to, in question 1, it says match the phase picture in figure 1 above with the lettered position, that is, put the phase number in the appropriate square box, the little square box there. And remember that the lit side of the moon always faces the sun. So one way we could do this is to look at some sort of the extreme cases, that is, look at these ones that are closest to the sun and then look at the ones that are furthest from the sun and then fill in some intermediate times. And I'm going to go ahead and do that with this one. For position D here, position D was really close to the sun on our sky, which means that it would have to be a very thin, very, very thin crescent. And of the pictures that I'm given here, I have either option picture 3 or picture 1. And we, of course, remember that the lit side of the moon always has to face the sun, because the sun is what makes the moon light up. So that means for position D, I would need to have picture 3 being that, fill in that box there. And that would leave then, for position E here, that would leave picture 1 for that one. So, if I were to actually draw them in, I'd have a very thin crescent here with the lit side facing the sun. And then for position D, I'd have a very, very thin crescent here again with the lit side facing towards the sun. And then for these other really extreme positions over here of either position A or H, we'll go ahead and take a look at position A first. This one, of the ones given here, it looks like I'd have a choice of either position 4 or position 5, or picture 5 here. And I'd want to have the lit side of the moon facing towards the sun if I was over here at position A. So that looks like number 5 is going to go in that box. And then over here, if I have it half lit up, I would want picture 4 to be that one there, so that the lit side is towards the left side, because the sun would be to the left of position H there. And then I just got to fill in some other numbers for these other boxes here. So I know I'm going to go from a very thin crescent then to finally to a quarter phase. I'm still going to go to a fatter and fatter crescent as I go this way, as I go towards the left on the page here. So So this one I had is number 3. I'm going to want a little bit fatter crescent, but lit up on the right-hand side, so it looks like number 6. And then for position B, it looks like I'm going to need to be number 2. And then for position F and G, which ones am I going to put in there? Well, again, as I go further away from the sun, I want it to be a fatter and fatter crescent. But I'm going to have the crescent lit up on the left-hand side. So for position E, we had was picture 1, and then I need a little bit fatter crescent. Looks like 8. And then a fatter crescent than 8 looks like number 7. There. So from left to right across the page here in the little square boxes, we would have 5, 2, 6, 3, 1, 8, 7, and 4 for those phase positions. Now, this snapshot then is telling you that these particular phases, this is where they would be on the sky at what time? At noon. So at noon, we would see this first quarter phase, looks like here. That first quarter phase would just beginning to rise up. Now it takes every object, 12 hours to go from rising to setting. So it means it takes 6 hours to go from rising to being at the midway point. So from here to here is 6 hours, which means then that this first quarter phase is actually 6 hours behind the sun. Okay, to go from south to east, that'd be like 90 degrees on our sky there, and that corresponds to 6 hours of time. So again, this first quarter phase would be 6 hours behind the sun. And what would we say about position H here? Well, this was actually a third quarter moon. It was number 4 here. We had that one being at noon. It was actually about to set there. So 6 hours ago, 6 hours before noon, it was actually there on the meridian. 6 hours before noon, then it would have been at 6 a.m. It would have been there on the meridian. So this one here, this one is 6 hours ahead of the sun. And then all of these other phases are at they're less than 6 hours difference from the sun, because they are closer to the sun on our sky than either phase or position A or position H there. Okay, so question 2 sort of restates what I was saying there. The sun is due south at about noon. The lettered positions are the various phases of the moon at noon. The Earth spins such that objects rise in the east and set in the west. So they move this way. Everything moves that way across the sky just because of how the Earth spins underneath them. It makes the objects appear to move across the sky that way. And since the Earth spins 360 degrees in 24 hours, that means it takes 6 hours to spin 90 degrees. So it takes 6 hours to go from east to south, and another 6 hours to go from south to west. It says it takes 6 hours to spin 90 degrees. The sun and the moon will take 6 hours to move from due east to due south, where the meridian is. So put the time that the phase crosses the due south line in the rectangles. Okay, so what we're going to be putting in the boxes then, or in these rectangle boxes here, is when that particular phase would finally be right here at this position on the sky. And so I'm going to start here with our first quarter phase. It looked like that. We knew that this one is 6 hours behind the sun. So 6 hours after 12 o'clock noon would be 6 p.m. So I'd put in 6 p.m. there. And I know that over here, the other extreme, this particular quarter phase is 6 hours ahead of the sun. So 6 hours before noon, what would that be? Well, 12 noon minus 6 hours, that is 6 a.m. So at 6 a.m., this phase would have been right here on the meridian, and the sun, well, if I again have the sun being my index finger and the moon, this being the pinky, 6 hours ago it would have been sort of like this, so that quarter phase would have been there on the meridian, and then the sun would have been rising off over here at 6 a.m. And then we got to put in some other intermediate times for these ones here. And this one I'm going to say is 4 p.m. I'm going to be a little bit arbitrary on that. I'm going to say that this is 4 p.m. It's supposed to be a P there. And this one I'll say is 2 p.m. And this phase here looks like it's just maybe 1 hour difference from the sun, so I'll say it's 1 p.m. So 1 hour later it will be 1 hour later it will be right there on the meridian. And these other ones here I'm going to have to be nice and symmetric with respect to these here. So this one I'm going to say is like 1 hour ahead of the sun, just like this one was 1 hour behind the sun. So let's have this one being, it was on the meridian at 11 a.m. and at noon it's already here in the western sky. For position F, if it's sort of like the counterpart of position C over here, this one was 1 hour different from the 1 p.m., 1 hour between 2 p.m. and 1 p.m. So I'm going to have this one being 1 hour between 11 a.m. and, well, this would be 10 a.m. then. This one is a little bit before that one, because that means this one was on the meridian at 10 a.m. This particular phase would have been a little bit further ahead of the sun than that very, very thin crescent is here. And then that leaves for position G, if I had this one being 4 hours behind the sun over here for position B, I'm going to have this one being 4 hours ahead of the sun over here. So 4 hours before noon means that it would have been on the meridian at 8 a.m. And then we'd again have this quarter phase being 6 hours ahead. It would have been on the meridian at 6 a.m. So to fill in then there are other boxes here. Does position H cross before noon? That is this one here. Yes. This one crossed the meridian at 6 a.m., so it is definitely before 12 noon. So we would say yes for that one. And we'd say that this one is ahead of the sun. And for position A here, does it cross before noon? Well, we said here that it crosses at 6 p.m., which is definitely after noon. So we'd say no, it's not before noon, and we'd say it's behind the sun. Now for the next page, we have a similar situation. We have a snapshot of the sky. We've got the sun is not at the meridian, instead it is setting. So we know this is the 6 p.m. positions of, this is going to be positions of the moon at 6 p.m. The sun tells us that it's at 6 p.m. because it's setting there in the west. And like we did for questions 1 and 2, we're going to be filling in the boxes. The little small square boxes are going to be the corresponding pictures of the moon. And then the rectangles are going to be when those particular phases would be there on the meridian. So we know that this position E here is fairly close to the sun as we see it on our sky. So we know it's got to be a crescent phase. And that leaves us with either picture 7 or picture 2 as being the one. Well, we need to have the lit side of the moon facing the sun. So we would need to have, the phase looks something like that. That looks like picture 2. So I'm going to put in picture 2 for that one. And I know that from southeast, that's 90 degrees there, since we had in a previous question there. That's 90 degrees. So we would need to have this phase being half lit up, and so that's either picture 4 or 5. And again, we need to have the lit side has to be facing the sun, because the sun is what lights it up. So we have this being picture 5 right there. And then I've got picture A as my other big extreme here. This is all the way across the sky. That would, if the moon is rising here as the sun is setting, 180 degrees opposite would be the full phase. So we know that one's got to be 8. Put in 8 for that one. And then we put in some other intermediate phases here. We know that these phases here would have to be in between a full phase and a quarter phase. So we know it's got to be a gibbous phase. And of course we know that the lit side has to be facing towards the sun. So it looks like we're looking at either pictures 1 and 3 to put in these slots here. And to choose which of 1 and 3 you put in for these two boxes here, well, we know that as the moon gets further from the sun, the more of it is lit up. So we know that the gibbous that is closer to this particular position is not quite as lit up as the other gibbous. So that leads me to say that this has got to be picture 1, and then this has to be picture 3 there. So from left to right across the page, we have 8, 3, 1, 5, and 2. Now to put in the rectangle boxes would be when those particular moon phases then would finally reach the meridian. And this particular position is probably the easiest one because it is on the meridian, and we know the particular time of day. This snapshot is all taken at 6 p.m. So at 6 p.m. that first quarter phase is on the meridian. And we have a clue here for this one. It says this position is halfway between south and west, and we know that from south to west is a total of 6 hours of time. Halfway between that would be 3 hours difference in time. So from here to there, from there to there is 3 hours of time, and from position E to the sun is 3 hours of time. This one would then have been 3 hours behind the sun. The sun was on the meridian at the sun was on the meridian at noon, which means this particular phase would have been on the meridian at 3 p.m. 3 hours difference from the sun, and also 3 hours difference from this particular phase here. So we've got that one was we could figure that one on out. Then we've got position A here is another extreme sort of position that we can use. We know that this full moon we had as the full moon was a full 12 hours behind the sun. And so it's rising at 6 p.m., which means 6 hours after that it will finally be there on the meridian. So 6 hours after 6 p.m. would be 12 midnight. So I'm going to go ahead and put in 12 midnight. 12 mid there for 12 midnight. And then I just put in some other reasonable times in for these other rectangle boxes. This particular phase here, this is a very big waxing gibbous phase. It's about 1 hour difference from this particular full phase there. So instead of 12 midnight, I would say it's about 11. I'd say it was 11 p.m., which means that this particular waxing gibbous phase, we had picture 3 there, was a full 11 hours behind the sun. Okay, not 12 hours for the full phase, but it was 11 hours behind the sun. And the sun got on the meridian at noon time, so 11 hours after noon would be 11 p.m., and that's when this particular phase then would finally reach the meridian. Now at 6 p.m., this particular phase is over here in the southeastern sky. But 11 p.m., so a few hours later, it's finally going to be there on the meridian. And then finally for phase C, here we had that was again this gibbous phase there. Looks like it's about 1 hour difference from this particular phase there. So I'm going to say instead of 6 p.m. I'm going to have that one being 7 p.m. For that one there. So from left to right across the page for the rectangle boxes we would have 12 midnight, 11 p.m., 7 p.m., 6 p.m., and 3 p.m. For questions 5 and 6 then, in the picture of the 4 phases above, which phases are always near the sun on our sky? That is a small angle from the sun. Well, those that are a small angle from the sun, they're going to appear to be a crescent phase, which leads us to be either pictures 1 and 4. And so if I were to actually maybe draw a little picture of the sun here, and then I would have phase 1 being pretty close to the sun as that one with the lit side facing the sun, and then I'd have another one over here for that waning crescent being right there with the lit side again facing the sun, but it would be on the left hand side. For question number 6, it says in the picture of the 4 phases above, which phases are always far from the sun on our sky? That is a large angle from the sun. These are the ones that are going to be more lit up, so I'm going to pick phases 2 and 3. So if I were to sort of draw them again on our sky, I'd have the sun, let's say right here, and then I'd have one phase, looks like picture 3 would be over there, very far from the sun, and then the other one would be over here, pretty far from the sun. And I can't draw gibbous very well, which is why I use a computer for these things here. So you notice that these ones would be a lot farther from the sun than how I drew these crescent phases there. All right, the next page just has you again notice that the larger the angle is between the sun and the moon, the more the daylit side of the moon we see. And also notice that the larger is the angle between the sun and the moon, the greater is the difference in time between when the sun is due south and when the moon is due south. And it says, double check your answers to 1 to 6 to make sure they are logically consistent with these two facts. And of course, we've already taken care of that. Now for questions 7 and 8, it's referring back to figure 1. So I'm going to bring that here. Here's figure 1. And I'm going to adjust this so we can see both of these things here at the same time. In figure 1, what was the time interval between when the sun was due south and when position G? Well, position G was this one here. And that is about how many hours between when position G was due south and then the noon time. Well, we had position, and for this again, was for question in figure 1, position G. We said that was up highest at 8 a.m. Now at noon, it had already moved off over here. It was getting close to setting, but at 8 a.m. it was here up highest. It would have been up here highest on the sky. So we said that was this one was 4 hours ahead of the sun. you know, 12 noon minus 8 a.m. would be 4 hours difference. So this one was 4 hours ahead of the sun. And so then if I fill in the answers here for questions 7 and 8, we'd say that this is 4 hours. It's 4 hours difference. That's the interval of time. And question 8 is very similar to number 7. We'd say it's 4 hours, and is it ahead or behind? Well, we said that one was ahead of the sun. And so now for question number 9, figure 4 below shows the positions of a particular waning crescent moon. That's all of these ones here, at various times of the day. Now, using your answers to 7 and 8, which we had here is 4 hours ahead, fill in the boxes in figure 4 with the time of day for each of the crescent phases. And notice that this phase picture would be in position G of question number 1, which is what it was saying up here. So, and if you need to change your answer to number 1, you would do so now. We've already taken care of that. Remember that it takes the moon 6 hours to go from due east here to due south, that is being there along the meridian, and then another 6 hours to go from the meridian to setting there in the west. Because in this very simplified model, we're having everything up for exactly 12 hours. So we'll go from 12 hours from rising to setting, which means it takes 6 hours to go from east to being up highest in the sky. And we already know from question number 1 that this particular phase was up highest at 8 a.m. And we also know that because it's 4 hours ahead of the sun. So 4 hours before 12 o'clock noon would be 8 a.m. This one would be there on the meridian. And if it's on the meridian at 8 a.m., it means 6 hours before then, it was rising over here. Well, what is 6 hours before 8 a.m.? Well, 8 minus 6 is 2. So at 2 a.m., it would have been rising. And if it rises at 2 a.m. and it takes a full 12 hours to go all the way across the sky to finally set again, that means that it would be setting over here at 2 p.m. Okay, 2 a.m. to rise means 2 p.m. to set. And halfway in between that we have as the 8 a.m. And then we just need to put in some other reasonable times in for there. And so I'm just going to go ahead and put in some other times here. So at 2 a.m. it was rising. At 3 a.m. it would be a little bit up higher in the sky there. Oh, let's say this is, I'm going to say it's just 5 a.m. If you put in 4:30, that's fine. But I'm going to put in 5 a.m. for that one. It's a little bit up higher in the sky. And I'm going to say this one looks like it's pretty close to 8 a.m. Looks like it's closer, maybe this is closer to 8 a.m. than it is to 5 a.m. So I'm just going to say it's 7 a.m. Again, I'm just putting in some arbitrary sort of times in there. And then for these other ones, I'm going to, just for clarity, I'm going to have them be sort of nice and symmetric with what I had over here. So if this one was 7 a.m., 1 hour difference, I'm going to have this one being 1 hour, further ahead in time. So at 9 a.m., this particular moon phase has moved to being right there on the sky. And then, let's see, this one I had, this was a 2 hour difference in time between 5 a.m. and 7 a.m. So I'm going to have this one being 2 hours difference there. I'm going to have that one being 11 a.m. there. These ones I had as 2 hours apart as well, so I'm going to go ahead and have these being 2 hours apart as well. I'm just being, sort of arbitrary on them, but just to be nice and symmetric with what I have over here. So 2 hours difference from 11 a.m. would be 1 p.m. and then I would have it finally setting there at 2 p.m. So for this particular phase, this is where you would see this particular phase at these given times right up here. It would be on the meridian at 8 a.m., it would be rising at 2 a.m., and at 3 a.m. it would be a little bit higher up in the sky there in the southeast, a little bit even higher at 5 a.m., almost due south at 7 a.m., and then finally due south at 7 a.m. And then it would start moving off over there in the southwest by 9 a.m. and then 11 a.m. there, about, roughly halfway there in the southwest, and a little bit lower down at 1 p.m. And then finally at 2 p.m. we would see that particular phase setting there. Now for questions 10 and 11, it says refer back to figure 2. Okay, refer back to figure 2. So I'm going to bring that up. I'm going to have this below here so we can see both of them at the same time. So figure 2 we have here. And it says, what is the time interval between when the sun was due south at noon? Okay, of course it would be due south. The sun would be due south at noon. And when position B was due south, it's this one here. All right, well, we said that for position B was due south at 11 p.m. That is 11 hours after the sun was on the meridian. The sun was on the meridian at 12 noon and 11 p.m. This one would finally get there. So that's 11 hours difference. So we know this is going to be 11 hours. And position B there of figure 2, that particular phase, which recall was that that waxing gibbous phase there. That one is definitely behind the sun. It's trailing behind the sun there. It's 11 hours behind the sun. And I'm going to use this fact here. It's 11 hours behind the sun for questions 12. Okay, so for question 12, figure 5 below shows the positions of a particular waxing gibbous moon at various times of the day. Using your answers to numbers 10 and 11, fill in the boxes in figure 5 with the time of day for each of the gibbous phases. And notice that this phase picture would be in position B of question number 3, which is what we just said previously. And remember that it takes the moon 6 hours to go from due east to being due south on the meridian. And of course, then it would also take 6 hours to go from the meridian to finally setting there in the west. And I'm going to put here at the top, just for us to remember, that for questions 10 and 11, we said that this phase was 11 hours behind the sun. So 11 hours behind the sun. And so we know at 11 p.m. this particular phase would be there on the meridian. And then to make this, to try and fill in some of these other times, what I would do would be to remember that it takes 6 hours to go from rising here in the east to being up highest there on the meridian. I would fill in this time and then this position here, and then I could fill in these intermediate times using that information. So I know that 6 hours before 11 p.m., this phase was rising. Well, what's 6 hours before 11 p.m.? Well, what's 11 minus 6 is 5. So we know at 5 p.m. this is rising up. And if it is rising at 5 p.m., then when would it set? Well, 12 hours later, it would be over here. So if it rises at 5 p.m., it has to set at 5 a.m. And this, we have a box, or this label here tells us that it gives us a particular time we need for this one, for this phase position there. That says this position is halfway between south and west. So that means it's 3 hours difference from the set time, and also 3 hours difference from being there on the meridian. And what is 3 hours after 11 p.m. and 3 hours before 5 a.m.? Well, that would be 2 a.m. So at 2 a.m., this particular waxing gibbous moon would be there in the southwestern sky. At 11 p.m., it was up highest there in the sky. And then finally at 5 a.m. is when we would see it setting. So if you got up a little bit before sunrise, you would see that that waxing gibbous moon would be there just about to set. And then we got to put in some other reasonable times in for here. They have to be sometime between 5 p.m. and 11 p.m. And I'm just going to say arbitrarily that this is going to be, say, at 6 p.m. it would be up a little bit higher there in the sky. And then finally at 10 p.m. It would be up high there, but still in the southeastern sky, not quite at the due south position. So from left to right across the page, I have here 5 p.m., 6 p.m., 10 p.m., 11 p.m., 2 a.m., and 5 a.m. So again, these times in these boxes, these are when this particular phase is at these given positions on the sky. For question 13, it refers again back to figure 2. So I'm going to bring figure 2 back here near the bottom of this. Here's figure 2. It says, now looking at position E, that was this one here, and position E, we had it being this picture, that crescent picture there. Position E was close to the sun, so the moon was a crescent. In question 4, what was the time difference between when the sun was due south, that is noon, and when position E was due south, that is about how many hours? Okay, so in question 4, we had filled in this one being at 3 p.m. It was on the meridian. So that was a 3 hours difference from what the sun was, 3 hours behind the sun. So I would say then here it was 3 hours. I'll go ahead and it's 3 hours behind the sun, just to remind me there. And now for question 14, it says, the phase picture below shows the waxing crescent phase for position E of figure 2. Now using the pattern of rising and setting motions of the moon from the waning crescent and waxing gibbous examples that we did up here, in the previous questions, give the appropriate time of day for the given positions. So when would this particular phase be rising? And when would it be midway up in the west? When it would be highest up due south? And when would it be low in the west, almost setting there? Well, if it's 3 hours behind the sun, we know that the sun rises at 6 a.m. and therefore this phase, being 3 hours behind the sun, would rise 3 hours after 6 a.m. So we know that this would have to be 9 a.m. And if it is rising in the east at 9 a.m., then we know that it would be low in the west, there about setting. I'm going to say is at 9 p.m. Well, it says almost setting. If you want to say 8:45, that would be okay. But I'm just going to keep nice round numbers here. It's there. It's there on the horizon at 9 p.m. If it's there on the horizon rising at 9 a.m. That's good enough. If you wanted to say 8:45, that would be okay as well. Now, when is it up highest? Due south. See, you notice I'm sort of doing these in a different order than A, B, C, and D. That's because when I do all of these things, I try and figure out like when is it up highest, or when is it going to be rising, and then when is it going to be setting, and then I'd pick then I'd fill in those midway times at a different after all of those. So I'm going to here. When is it up highest due south? Well, it's 3 hours behind the sun, so I know that would have to be at 3 p.m. If the sun's up highest at 12 noon, then 3 hours after that, it would be 3 p.m. for that particular phase to be up there on the meridian. And then midway up in the west. Okay, well, we need that one to be, well, 3 hours after it's up highest, and 3 hours before it's setting. So 3 hours after 3 p.m. and 3 hours before 9 p.m. is 6 p.m. Now let's take a look at question 15. It says, now for a totally different phase than what has been given so far. For the phase picture below, give the appropriate time of day for the given position. And notice that it is different than for figure 5 that we had up here. This was a waxing gibbous phase. You see it's lit up on the right-hand side. This one is a waning gibbous that's lit up on the left-hand side. And it says this is a waning gibbous that would be below the ground in figure 2. If we go back to figure 2, I'm going to bring that forward here. In figure 2, the waning gibbous would have been here. That's that dashed thing there, and it says for number 15. At sunset, that particular phase would still be below the ground, and so we would have to wait till after 6 p.m. to finally see it rise up there. It's like this particular phase here would have been like an hour even after the moon would have risen. This full moon would have risen. The full moon we had rising at 6 p.m. when the sun was setting over here. So this one would finally get up above the horizon then at, say, at 7 p.m. And I'm going to use that then to fill in these other times that are given here. We know that the full moon is 12 hours behind the sun, which means then that if we had the moon over here at this waning gibbous, we could say that this thing would be 13 hours behind the sun. And that's the same as saying that it is 11 hours ahead of the sun. So however you want to work that, either 13 hours behind the sun or 11 hours ahead of the sun, those two are equivalent. I'm going to go ahead and just write in here that this phase rises at 7 p.m. just so I have that as a reference. And if it rises at 7 p.m., then I know when it would be setting. It would be setting 12 hours after that. And what's 12 hours after 7 p.m. is 7 a.m. So that means in the early morning, just after the sun rises, we would see this particular phase off over there, just beginning to set. And when would it be up highest, due south? Well, we know it rises at 7 p.m. and we know it sets at 7 a.m. we need to have a time that's midway between those two. It would need to be 6 hours after 7 p.m. And maybe it's here where you could use your fingers to count up the 6 hours. 8 p.m., 9 p.m., 10 p.m., 11 p.m., 12 p.m., 1 a.m. So at 1 a.m., it would be up highest due south. We know that it sets at 7 a.m. midway up in the west we need midway between 1 a.m. and 7 a.m. So that would be 3 hours after the 1 a.m. So 1 plus 3 is 4 a.m. And then this is probably the trickiest one, maybe the trickiest one here. Midway up in the east, well, it would be, we know it rises at 7 p.m. and 3 hours later it would be midway up in the eastern sky. So 3 plus 7, all that's 10 p.m. for that one. Which means for this particular waning gibbous phase, we would see it rise at 7 p.m. It would be midway up in the east at 10 p.m. It would be up highest at 1 a.m., then midway up in the west at 4 a.m., then finally setting there in the west. So I had these A, B, C, and D purposely mixed up there to help you, just to try and get you to work with a given particular time there. But maybe it would be helpful to just go ahead and maybe make a drawing of when you would see these. So we'd have this phase, I'm just going to say over here at 7 p.m. it'd be rising up. At 10 p.m. it would be there up in the sky, and then due south it would be highest up at 1 a.m. Put 1 a.m. there. And then midway up in the west would be over here. This would be 4 a.m. And then finally it would be setting off over there at 7 a.m. That's what we would see it rising in the east and setting in the west off over there. So for these first several questions, first 15 questions, we've been looking at different phases, when they would be up highest on the meridian and where their positions on the sky and all that. And now what we're going to do is to sort of switch gears here a little bit. And now we're going to take a look at the orrery view. That is what it would look like from space. So if you were high above the Earth, what would the moon position be for the different phases? I do have these example sheets in your student guide there, orrery to ground view, that show you, given a particular position there in its orbit, what phase would you see there, and actually how you could figure that out. So I encourage you to do that. And here is a view of the Earth and Moon from high above the Earth's North Pole. So the North Pole would be right there. We're looking high above it there. The Sun would actually be way off, much further away than what I've drawn here. So this is obviously not to scale. And here's the Earth's shadow. You see it's pointing off over that away. And you'll notice that the Moon is not in the Earth's shadow, and but even though the Moon is not in the Earth's shadow, we would definitely see it going through all of the different phases there, because the Earth's shadow does not cause the Moon phases. The Moon phases are due to the position that the Moon is with respect to the Sun on our sky. Or that another way to say that is it's caused by the angle that it is with respect where it is in its orbit on around. For question 16, says which moon position A to E best corresponds with the moon phase shown in the upper right corner of figure 6. Make sure that the moon position you choose correctly predicts a moon phase in which only a small crescent of light on the left-hand side of the moon is visible from the Earth, and enter the letter of your choice here. And remember that the position of the moon in its orbit determines what phase we see if we're standing here on the Earth looking out towards the moon. When the angle is small, like from E to the Earth to the moon here, that's a small angle there, we would see it in a crescent phase. So we know that for this phase here, it's either going to be E or D as our possible ones for this. And in the orrery to ground view example sheets, I had a picture of the moon being at this position with respect to the Earth and the Sun, and I showed that particular moon phase would look the opposite of this, so it was actually looking like that. So we know that this is not the corresponding one for that one. It's actually going to be choice D, and I'm going to show you how you can use this orrery to ground view example sheet to show you how we get to that particular picture. So going through the process that was used on these orrery to ground view, I'm going to have my my stick figure, so that'd be like you standing on the ground there. And as I had it in those pictures example sheets, I had the person raising his right hand, so I'm going to say that is his right hand, and then his left hand was over there, was facing down. And so if you were looking towards the moon this way, we would draw the line there perpendicular to, we'd see that the left side, there's a little sliver of light that would be right there, that would be lit up there on the left hand side. Maybe if I can make this a little bit bigger. So if I have position D looking a little bit bigger here, we were facing, this was to the Earth. So you'd have your stick figure here. We had this line going from Earth to the moon, as I do it there in the example of orrery to ground view. We had a line going from the Earth to the moon, to the center of the moon, and then we, in that example of orrery to ground view, we do it another little perpendicular line like that. Oh, I'm sorry, I forgot to draw in where the moon was lit up in this picture here. D, this was all dark there, this space view there. And okay, so now we have, if we were here on the Earth looking this way towards the moon, we see that on the left-hand side there's this little sliver of light that was visible, and that would correspond to the a true round moon, spherical moon. It would be a crescent phase there. So it would be lit up on the left-hand side. And then put in in the blank boxes below, sketch how the moon would appear from the Earth for the moon positions that you did not choose in question 16. And be sure to label each sketch with the corresponding letter indicating the moon's position from the figure above. And note that positions B, C, and D would have the observer facing downward. Okay, so it's just B, C, and D, we'd have to have the observer facing downward on the page here. So I'm going to go ahead and have this picture is going to be for picture E, for position E. That one I know is a crescent, but it's the opposite crescent than what we had for D up here. so it's lit up on the right-hand side. And shade in the part that is dark is seen from the Earth. So of course that's all shaded in. So I'm going to go ahead and do that. And then I'm going to go around this way here in chronological order. As the moon moves around the Earth in this direction in space, it moves in a counterclockwise orbit. So here, this would be the waxing crescent. If I had something here, this would be first quarter phase. Then over here, this would be a gibbous phase. So I'm going to have that be, I'm going to label that as A. And I'm going to go ahead and draw in, I know that this one, position A, would also be lit up on the right-hand side. So I'm going to draw, it's going to look sort of like a crescent line here just for my boundary, but I'm going to shade in that part there so that it looks like a, it's gibbous and then it's lit up on the right hand side. And then I'm gonna go ahead and label this one being position B. Position B is also a gibbous phase. If the moon was right in here, and if it was actually a little bit above or below the moon's the Earth's shadow there, we would see it in a full phase. But it's a little bit further along here. It's in a gibbous phase, and this time it's a waning gibbous. Waning meaning that it's going to be lit up on the left-hand side. So I'm going to go ahead and again draw my little crescent boundary there between the day and the night, and it's going to look like A but just flipped over 180 degrees. So I'm going to shade in that part there, and here it's a waning gibbous. It's lit up on the left hand side. Again, if you go back to the orrery to ground view example sheets, I have a step-by-step drawing showing how to get to that there. And now for part C, position C there. This is in that third quarter phase. Here we would have the observer would be facing, it's sort of in the down direction there. I'm going to go ahead and redraw that down here. So here's the Earth. Here's the stick figure guy, person. The person is raising his right hand, is lowering his left hand. So this is the person's right hand side. And here's the left hand side of the person. And the moon is down here. And so for this person, the lit side is on the left. So I'm going to draw a line down the middle, well, approximately in the middle. I'm going to shade in the right side, and the left side, well, approximately there, is that's that letter C there. And certainly for the third quarter phase, it is lit up on the left-hand side, and it's half lit up. Now for this section of the Lunar Phases worksheet, this particular piece here is really very helpful for doing the mapping from the solar system, mapping the solar system from the Earth project, which I do in the face-to-face classes. And it's also very handy for a lot of the different quiz questions and exam questions that we'll have. So I encourage you to go through this piece here as well. And what we have here, the orrery view, again, remember, is this view from high above the Earth up in space. And we have views of the Earth from high above the North Pole. So the North Pole is right there at the very center of the circle crosshair there. And there are some key facts that we have in our solar system. Number one is that the observer's location on the Earth always faces directly towards the sun at noon. That's by definition. So, it takes the Earth 24 hours to spin on around, And at noon, your part of the Earth is facing towards the sun. That's by definition. And in these, of course, in these pictures, remember that we have the sun is way off, towards way off the right side of the page there. This is not to scale there. The second key fact is that the observer's location on the Earth always faces directly away from the sun at midnight. So 12 hours after noon, you'd be facing that away, directly away from the sun. And third key fact is that the Earth spins in a counterclockwise direction as viewed from high above the North Pole. It's just the way the Earth spins, counterclockwise in that way. So I've got a big fat arrow there pointing you to that. The fourth key fact is one that people often forget, but it's a really important one to remember, is that the observer's location on the Earth points due south towards the meridian at any given time. The meridian, the due south direction, rotates with the observer. What that means is that there is no north, south, east, and west in space, is that north, south, east, and west is all relative to you, to where you are on the Earth. And so that means that the due south direction is going to spin on around there as the Earth spins you on around with it. So let's go take a look here at question 18. Using the key facts in figure 7 above, that was this here, enter the observer's time of day, that is it noon, 3 p.m., 3 a.m., etc., into each corresponding box next to the 4 observers and answer the following questions with the compass direction the observer's location on the Earth is facing at that time. And remember that the Earth takes 6 hours to spin 90 degrees. And pay attention to that last key fact when filling out the compass directions below. So let's first fill in these boxes here. And we know at noon, our part of the Earth was facing directly towards the sun. 6 hours after that, our part of the Earth would have been facing, this way, or as I've drawn it here, would be in the up direction on the page. That would correspond to 6 p.m. And so what if we were right here, midway in between? Well, what's midway in between noon and 6 p.m. or sunset? Well, that would be 3 p.m. So at 3 p.m. we would be facing sort of that away. Or as I've drawn it here, sort of this upper right part of the page there. And that's because I have the sun off towards the right-hand side of the page. This is my noon direction. So I'm going to go ahead and actually write that in just so I don't forget there. Then for observer B, well, observer B looks like he is midway in between my sunset and my midnight here. Midway in between 6 p.m. and 12 midnight would be 9 p.m. So at 9 p.m., as I've drawn it here, the person would be facing sort of towards that upper left part of the page there. Then for position C, well, position C looks like it is midway in between midnight and sunrise. And that looks like then between 12 a.m. and 6 a.m. is 3 a.m. And you may notice that it's pretty symmetric with what I have up here. If this was 3 p.m., then 12 hours later has to be 3 a.m. And maybe you can guess then that for position D here, it's got to be 12 hours different than 9 p.m. Well, that's got to be 9 a.m., which is halfway in between the 6 a.m. of sunrise and the noon position of 9 a.m. Okay, now to fill in this part here, this is where it gets a little bit tricky. It says the compass direction the observer A's location is facing at 3 a.m. And pay attention to that last key fact when filling out the compass directions below. That last key fact says that the observer's location on the Earth points due south towards the meridian at any given time. The meridian, due south direction, rotates with the observer. So at 3 p.m., observer A is facing that away. And what direction is that? South. 3 p.m., person, that south direction is that away. And what happens to that due south direction? The meridian due south rotates with the observer. So at 6 p.m., it would be facing straight up. At 9 p.m., due south would be this way. So observer B is facing what direction at 9 p.m.? He's facing south. South rotates with the observer. So 9 p.m., south would be the direction of my pencil. And then 3 hours later, south would be that away, directly towards the left, directly away from the sun. So at midnight, it's that direction. And then at 3 p.m., the observer, there's observer C, that person is facing what direction? South. So at 3 a.m., that's south. And again, due south rotates with the observer. So at 3 a.m., it was facing that away towards the lower left of the page there. At 6 a.m., south would be directly towards the bottom of the page. And then 3 hours after that, at 9 a.m., we'd have south facing in the same direction as observer D is right there. We'd have it facing that away. So observer D is facing south at 9 a.m. So south, 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 south. All right, the last page of the Lunar Phases Worksheet is combining the aura review time of day with the moon phase practice. So here we have positions of the moon on around the Earth. And in this space view, the moon's always half lit up. If you were high above the Earth-Moon system, you would see the moon always half lit up there. Now, of course, here, if we're standing on the Earth looking towards the moon, then we see different amounts of the moon's daylit side facing towards us. So we have the views of the Earth and the moon from high above the Earth's North Pole. So the North Pole is in the center of the circle crosshair. So there's the North Pole right there. And let's see, it says here for number 19, enter the time of day, that is noon, 3 p.m., 9 a.m., etc. Each moon position will be in the due south position into the box next to each moon position. Now remember that the Earth takes 6 hours to spin 90 degrees, and each observer is facing due south at each particular time. That is, south rotates with the observer. Remember, that's what we did in question 18. With this aura review drawing, you are finding when each moon phase will be highest up in the sky, that is, along the meridian. Well, we know the first key fact is that if I had a stick figure here and it's pointed right towards the sun, we know that that is the noon time. That's directly noon. And we know for observer, if you're facing directly away from the sun, that would be the midnight time there. So we know that this one here would be the midnight. I'm going to go ahead and write that in here. And I'm also going to go ahead and put in that time right here as well for the box. So observer 4 would see, if the moon was right there, it would be on the meridian right there at midnight. Remember that the Earth spins what way? In a counterclockwise direction. So I'm going to go ahead and put a big fat arrow there to remind me. And by the way, that's also the same direction that the moon moves around the Earth, is in a counterclockwise direction as well. But as the Earth spins, it moves us in this way. So we're going to start off here with observer 1. And at 3 hours after noon, that person would be facing right towards that phase there. That would be 3 p.m. And then 6 hours, or 90 degree from noon, 6 hours after noon, or the same as 3 hours after 3 p.m., we would have the observer facing this way. So this is due south at 6 p.m. We had this one being another 3 hours after that. That is 9 p.m. 3 hours after that is midnight. And if I had a stick figure here, that would be a 3 a.m. there. I go another 3 hours, and I have here at 6 a.m. So again, remember that the Earth spins in a counterclockwise direction, so it might always be helpful to draw that arrow if you have a picture sort of like this orrery picture. Have the Earth spinning that away, and at 6 a.m., here's the observer. So this is the due south direction at 6 a.m. And then 3 hours later, we are here at position 6. 3 hours after 6 a.m., that's 9 a.m. So I'll go ahead and put in that time there. So at 9 a.m., we'd be due south would be this direction here. Okay, now to put in the particular phases for all of these, as we would see them from the Earth. And the figure below are ground view drawings of how the moon appears to us on the Earth, and put the appropriate phase picture in the circles next to the time of day boxes in the figure 8 above. Well, we know that these two here, they're at a small angle with respect to the sun. This angle here would be small, be less than 90 degrees there. So we know these got to be crescent phases. The moon moves in this direction on around the Earth, and we would see this phase, then it would be lit up on the right-hand side. So we knew this one to be the number 2, corresponding to this one here. And then this one is lit up on the right-hand side. It's got to be a quarter phase. We know that one's got to be 4. For my picture down here, I'm going to try to get both of them in the frame here. If I were to actually sort of draw that, let me go ahead and draw in what it would look like. So 2 was looking like that. 4 was looking like this, sort of half lit up. Maybe go ahead and draw in shade in there. And this one was the crescent. And then this one would also have to be lit up on the right-hand side, but it would be a gibbous, which looks like it's picture 1 here. So I'm going to go ahead and put in 1 there. I'll go ahead and try and draw what it would look like. I'm not that good of a freehand drawer, but it would look something like that. And then this picture would correspond to the full moon. That's picture 6. So, it would just look like a full moon. This picture here would correspond to remember we would see it lit up on the left-hand side. There's this side here for this observer here. This person has his left hand down and the right hand is up there. So this person sees this moon is lit up on this person's left-hand side. So it would correspond to picture 3. So for this observer 5, he would see the moon looking like this. Let me draw a half there. It would dark like that. And then for person 6, again, facing towards the moon this way, there's his left-hand side and there's his right hand raised up. He would see the left-hand side lit up, and it would be a crescent. So it looks like it's going to be number 5 there. And so if we were to draw it in, it would look like, if I could if I can draw this in here correctly, it would look like that. So for these given phases, this is when these particular phases would be up highest in the sky. For this waxing crescent phase, which is picture 2, it would be up highest at 3 p.m. For the first quarter phase, which looks like that, it would be up highest at 6 p.m. When the moon moves over here in its orbit, we would see it in a gibbous phase, and it would be up highest, say, at around 9 p.m. When the moon is moved so it's directly opposite the sun on our sky, we would see it up highest when it's midnight, when our part of the Earth is facing directly away from the sun. And when the moon is moved to being this part in its orbit, well then we see it up highest at sunrise, or at 6 a.m. And then when the moon has moved to this part in its orbit, we would see it up highest at 9 a.m. and it would be a crescent, and it would be waning, because as time goes on, remember the moon moves in a counterclockwise direction, the same direction that the Earth spins. So as time goes on, the moon would be moving this way, and when the moon finally got into here, we would see it in that new phase. So remember, with all these videos, you can stop and rewind them to if a part wasn't clear.